All right, this is the Geometry Unit 7, Lesson 5 video. This video has this lesson has a lot of proofs on it, and so we are going to kind of do two main things. One thing, I'm just going to get you the kind of vocabulary and images that you need, because on the test there are no proofs, but you do need to know what these types of diagrams are called, or what, when you look at them, you need to know how to identify them. So I'm going to go through that first. So the main one they're introducing here, we have a circle, is called the, not quite a circle, is it? And is called an inscribed angle. And so an inscribed angle is any angle that has all 3 points on the outside of the circle. So we're talking about this circle here. If this is point A, point B, point C, this angle here, this is called an inscribed angle. So inscribed angle means, again, that 3 points on the circle. So the vertex and the other 2 points are on the circle in an inscribed angle. That's really like the main thing that you need to know here. But the big concept around inscribed angles is that if you know that the arc measure of an inscribed angle is, let's just say this is 120 degrees from here to here, then we know, based on the rules about inscribed angles, is that the angle is equal to 60 degrees. So with inscribed angles, they are equal to 1/2 the arc. So inscribed angles. Now, you don't have to actually know that for the test, but the proofs in this lesson are going to utilize this information and some other rules as well. But you need to know this is an inscribed angle. I'm telling you, that is the key that you need to know for the test. But the rest of this is going to be me going through some proofs. So let's look at this together. It says here, circle P has an inscribed angle BAC. So that's right here. We have inscribed angle BAC. And they want us to prove what we just talked about. They want us to prove that the angle is half the measure of the arc. So let's read through the different information we have in here so far. So they have our givens. We have statement 1, that's a given. It says that circle P has an inscribed angle of BAC. And then it says that draw radius BP. So they've added a radius here. They've added this radius right here to create a triangle. You can see that. And then they said that BPC, that's this angle made up of the pink and this blue, but I'll go ahead and outline it like that. The pink angle, that's this angle, is equal to the measure of the arc, and because that's the definition of the arc measure of an angle. Remember, central angles, which is what BPC is, are equal to the measure of their arc. Okay? So that's how they're able to prove that. Then it says the angle of BAP, just going to get my laser pointer out here, BAP plus ABP, this one plus this one, equal the measure of BPC. So this angle plus this angle equals this angle. And that's going to be from, and we can look at our answer choices, some kind of angle theorem. Let's find out what we got here. So is it segment? No. Equality, isosceles triangle, addition. There it is. Isosceles. No, I'm sorry about that. It's going to be exterior angle theorem, because we know from But back with triangles, and this is coming from the first half of geometry, we know that in triangles, if I have this, what we call an exterior angle, then if I add up this angle and this angle, they add up to that exterior angle. So that's coming from the exterior angles theorem. So a lot going on in this proof. Then it says AP is congruent to BP. Those are both radius. So those are going to be all radii on the same circle are congruent. Anytime you're looking at two radiuses or two diameters, that's going to be your theorem there. And then APB is an isosceles triangle. That's the definition of, surprise, surprise, isosceles triangle. Oops. And I messed that up. Let me go back and fix these. Make sure you get those right. So we have exterior angle theorem, all radii on the same circle are congruent, and the definition of isosceles triangles. Because of that, BAP and ABP are green angles here. The green angles that I already drew are congruent. That's because of the isosceles triangle theorem. And then the measures are equal because congruent angles are equal in measure. And then from line 4, it says we're doing something that's coming from this one is coming down here. So that means we've taken, it says BAP, BAP. Okay, so they've substituted. And we can see they've substituted this value with this value. And that's anytime we're replacing one angle for another or a segment for another, we're dealing with substitution. Substitution property. And then they're simplifying, simplifying, simplifying until we get down to the final answer there. So make sure you take a look at that, get those answers down so you can get through this lesson. But remember, the key here, I just want to remind everyone, is you need to know this definition of inscribed angles, which is why I'm doing these proofs for you, because I'm kind of giving you just the key information. Okay, let's go with it. We have two more proofs, I think. Yeah, quite a few. All right, let's keep going. Next one, circle P with EDG inscribed. This is an inscribed angle, EDG, with P in the interior. So we have EDG. Get that drawn in. And then they've drawn diameter DF going through point P. And then they've started by saying the measure of the angle is half the measure of the arc. The measure of this angle is half this measure of this arc. So how do we know that the measure of EDG is half the measure of EG? Well, it says FDG was added to both sides of the equation. That means we're doing some sort of equality property. So we're doing the addition property of equality. There should be an equal sign in that statement. This should say addition property of equality. All right. Like I said, sorry, I think it might have cut out. That should say equality there. It should be the addition property of equality. Then they're doing some substitution from line 3. So they're taking stuff from here and they're putting it into another one. Then they're distributing. They're distributing the 1/2 or undistributing the 1/2. It's actually more like factoring. They're doing transitive property. They're doing a bunch of equality properties to get down to number 8. And what they've done to get from 7 to 8 is you can see they've just taken, see, that's the same. That's the same. And now they've said, okay, 1/2 of this plus this equals EDG. Now, where did they get that from? So we have to go looking for that. Let's look at what our answer choices are. Okay. Something addition postulate. Well, we know we're talking about the angle addition postulate because we've got this angle plus this angle equals EDG. That's these two angles right here. That's this angle and this angle add up to make the angle in red right there. So that's the angle addition postulate. Then they're doing the arc addition postulate here. They're saying arc EF and arc FG. Let's run up to our diagram. Arc EF and arc EG equal arc this whole arc, which is the arc addition postulate. And then that's the end of the proof. Make sure you got your answers there. There's only 3 of them on that one. There got some more corollaries and more extensions of this theorem about the half arc angle relationship. So this one says you have quadrilateral ABCD. See that? That's inside the circle. It's inscribed. Prove that A is supplementary to C. Remember that in order to prove that A is supplementary to C, that means we need to prove that angle A plus angle C add up to 180 degrees. So that's what we're going to have to do here. So we'll see how we can get there. That's the definition of supplementary. So they've given us the quadrilateral. They've started by using one of the corollaries. Let's see, corollary 2, I think, is coming from up here. Let's find it. It's right here, corollary 2 of the inscribed angle theorem. So let's go look and see if that's one of our options. And there it is, inscribed angle theorem. Then they've said here they've added something to both sides. Anytime we do that, we're talking about addition property of equality. So I'll put my equal signs there because they're somehow missing. Then they say from line 2. So they're taking something from line 2 and they're bringing it down here. It looks like they've replaced something, angle C, with the measure of angle BAD. And so that must be substitution. It's my guess. Anytime you see something being replaced by something else, we're talking about substitution. And then they use the distributive property. And then you can see in this next one, they've brought A's down, brought C down. They replaced those with each other. And so that must be the transitive property. Or, let's see. Measure of angle A, measure of angle C is equal to, okay. See what we got here. Symmetric, addition property. It's got to be the symmetric or substitution property. There it is. I missed it. Substitution property of equality. Sorry about that. And BCD plus BAD equals measure of angle BAD. They've got a little issue here with the way this is written. This is going to be the arc addition postulate because we have arcs adding up to another arc. This should not be here in the statement. This is a typo. It should end right there. And then they finish it out there. I know this is a lot, so just bear with me and get through these proofs. Like I said, you just need to know what is in the on the vocabulary for the test. Speaking of which, vocabulary here, number 4, number 5, number 6. What kind of angle? What kind of angle did we talk about in this lesson? That should be the answer there. You need to look up these corollaries in the boxes above to answer these questions. They tell you. We also talked about this. The measurement ascribed angle is, it's right here on our notes. Here they're telling you which theorems to look at. Go look up in the note in the lesson itself to find the answers there. More of the same here. If inscribed, number 10, if inscribed angles in a circle or congruent circles intercept the same arc, then the angles are congruent. If they're congruent and the arcs or angles are congruent, then the angles have to be congruent. Congruent circles, congruent arcs means congruent angles. More of the same. Go look up at the corollary 2 for that one. And then we have, I think, just one more proof, or 2. Jeez. All right. Given circle P with HGI inscribed. Okay, that's this one right here. Draw diameter GJ. So let's add that in. Then they've said that HGJ is equal to half of HJ and IGJ is half of IJ. Then they've done some subtraction from both sides. That means we're using the subtraction property of equality. Again, there should be an equal sign in that statement there. Then they said they've done something from line 3. They're obviously doing substitution. They distribute, and then they're doing the substitution property again. I think maybe number 5 needs to have this one. Or no, sorry. There you go. Substitution for both of those. Then we're getting the addition, the angle addition postulate. And then again, we're subtracting from both sides. Anytime we're doing that, we're using the subtraction property of equality. And then we have the blank addition postulate. Well, what do you think we're adding here? We have arc symbols, arc symbol, arc symbol. So clearly this is the arc addition postulate. And then we're done. More of the same. Inscribed angle ABC, intercept circle, semicircle, ADC. That's this. So the measure of arc ADC is 180. We know that because that's the definition of a semicircle. Semicircles are 180 degrees. And they've drawn a diameter for us right here. The measure of angle ABC is half the measure of ADC. That's the inscribed angle theorem. That's what we learned about just in this lesson. And then measure of angle ADC is 180. We know that because they said it right here. So that's what we call substitution. The measure of ABC is equal to 90. That's just called arithmetic or simplify. We've simplified 1/2 times 180 to make 90. That's just simple working it out. And the definition of that is that it is a right angle. So it's the definition of a right angle. And that's it for lesson 5. Thanks for bearing with me through all the proofs. But again, I'll put this in the notes, but this information here is the key. This is the thing you need to know for the test. You don't need to know about these proofs, but thank you for sitting through that with me. And I'll see you on here for our last video for this